Hi, welcome to the class. So, electric current, electric current, electric current. So, CBSE Grade 10 Physics, CBSE Grade 10 Physics. So, blessings always, definitely. So, electric current, the rate of flow of charge, the rate of flow of charge is called electric current. Rate of flow of charge, electric current, electric current. Electric current is nothing but the rate of flow of charge I equal to Q by T, I equal to Q by T. SI unit of current is ampere, SI unit of current is ampere, SI unit of charge is coulomb. So SI unit of current is ampere, SI unit of current is ampere, SI unit of current is ampere, SI unit of charge is coulomb, SI unit of charge is coulomb, and SI unit of time is second, SI unit of time is second. So 1 ampere equal to 1 coulomb per 1 second, 1 ampere equal to 1 coulomb per 1 second. So here the rate of flow of charge is called electric current. The rate of flow of charge is called electric current. The rate of flow of charge is called electric current. Okay. So I equal to Q by T. I equal to Q by T. So I equal to Q by T. SI unit of current is ampere. SI unit of charge is coulomb. SI unit of time is second. 1 ampere equal to 1 coulomb per 1 second. So 1 ampere of current is defined as 1 coulomb of charge flowing through unit cross section area per second. 1 ampere is defined as 1 coulomb of charge flowing through unit cross section area per second is called is called 1 ampere. 1 ampere, right? 1 ampere is defined as 1 coulomb of charge flowing through unit cross section area per second, right? So that is about electric current. And next one, charges are moving inside of the conductor. So charges will move inside of the conductor. There are positive charges, negative charges, positive charges, negative charges. There are number of charges will move, so it won't be moving one or two. So if only one electron will move, we can't say charge current is flowing. Only two electrons, if it is flow, we can't say current is flowing. So there are many charges like positive charges, negative charges. Positive charges or negative charges are moving inside of the conductor. That's why it is integral multiple of charges. So that's why Q equal to charge is nothing but plus or minus Ne. Plus or minus Ne. That is nothing but plus or minus Ne, nothing but. So positive charges are there, negative charges are there. Positive charges are there, negative charges are there. Both are moving inside of the conductor. Both are moving inside of the conductor. That's why I'm taking Q equal to plus or minus Ne. Q equal to plus or minus Ne. So I equal to, we can take Ne by T. I equal to Ne by T. I'm taking I equal to Ne by T. I equal to Ne by T. So N is the number of electrons. Number of electrons are passing inside of the number of charges are passing inside of the conductor. Okay, so here if I'm taking electrons, so number of electrons. Now one question they will ask related to this one. That question is so here 1 ampere of current is flowing inside of the conductor per second. So how many electrons are present in 1 ampere of current? How many electrons are present? How many electrons are present in 1 ampere of current? So that is the question. If they ask like that, we need to find out. We need to find out like this. We need to find out. Okay, so I'm considering here. Okay, 1 ampere is the one I'm taking, and n into, so on one electron 1.6 into 10 power minus 19 coulomb. On one electron 1.6 into 10 power minus 19 coulomb. In 1 coulomb, how many electrons are present? In 1 coulomb, in 1 coulomb, how many electrons are present? We'll discuss now. In 1 coulomb, so in 1 coulomb, if you are taking 1 by 1.6 into 10 power minus 19. So electrons I am taking here. 1 by 1.6 into 10 power 19. Right? So 1 by 1.6 into 10 by 10 into 10 power 19. 10 power 19. So then you are taking 10 by 16 into 10 power 19. Okay, so if you do this one, you'll get 0.625 into 10 power 19 in 1 coulomb. So 6.25 into 10 power 18 electrons are present. So you can take here. So in 1 coulomb, 6.25 into 10 power 18 electrons are present. So very, very important, very, very important. Make a note of it, make a note of it, make a note of it. Okay. So here, in electric current 1 ampere, I equal to Q by T, I equal to Q by T. SI unit of current is ampere, SI unit of charge is coulomb. SI unit of current is ampere, SI unit of charge is coulomb. SI unit of time is second. 1 ampere equal to 1 coulomb per 1 second. 1 ampere equal to 1 coulomb per 1 second. So inside of the conductor, so there are many charges will move, so it is not only one or two. So if only one electron will move, so we can't say current is flowing. Only two electrons will flow, we can't say two electrons current is flowing. So there are many charges are moving inside of the conductor. That's why then only we can able to say current is flowing. I equal to Q by T. So quantization of charge, that is number of charges are moving inside of the conductor. That's why quantization of charge, Q equal to plus or minus Ne. Q equal to plus or minus Ne. So I equal to Ne by T. On one electron 1.6 into 10 power minus 19 coulomb. On one electron 1.6 into 10 power minus 19 coulomb. In 1 coulomb, how many electrons are present? So here you can see 1 coulomb 1 by 1.6 into 10 power minus 19 electrons. Okay. So now 1 by 1.6 into 10 power 19, 1 by 1.6 into 10 by 10 into 10 power 19. So if you do this one, you'll get 10 by 16 into 10 power 19, 10 by 16 into 10 power 19, that is 0.625 into 10 power 19, that is 1 coulomb 6.25 into 10 power 18 electrons are present. So here you can see, so in 1 coulomb 6.25 into 10 power 18 electrons are present. 10 power 18 electrons are present. Yes or no? So this is about charges, and in 1 coulomb how many electrons are present? In on 1 electron how much charge is present? So we are discussing this one. Okay, next one. Next one. Next. Electrical appliances. Electrical appliances. So next one we are going to discuss about electrical appliances. Electrical appliance. First one I am taking the cell. First one I am taking the cell. So this is the positive terminal, negative terminal, positive terminal, negative terminal. Okay, cell I am considering here. Cell, cell. Second one is battery. Second one is battery. Second one is battery. So positive terminal, negative terminal, battery I am taking. Battery I'm taking. Okay, so coming to the third one. Third one is switch, open switch. So I'm taking switch. This is the open switch, open switch, open switch. Next one is closed switch, closed switch, closed switch, closed switch. Fifth one, resistor, resistor, resistor. Sixth one is rheostat. 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 Okay, so next one, seventh one, ammeter. So eighth one, voltmeter. Voltmeter. Ninth one, bulb. Tenth one, wire joining. 11th one, wire crossing. Wire joining, wire crossing. Okay, so here you can observe this is a cell. So cell I am considering here. First one is cell, battery, open switch, closed switch, resistor, rheostat, ammeter, voltmeter, bulb. So this one I am considering the wire joining, wire crossing. Wire joining and wire crossing. Once again, cell, battery, open switch, closed switch, resistor, rheostat, ammeter, voltmeter, bulb, wire joining, wire crossing. So these are the electrical appliances. What are we are using? These are the whatever I'm. So you can see what are you are seeing on the board. Those are electrical appliances. Electrical appliances. Cell, battery, open switch, close switch, resistor. Resistor is nothing but. Resistor is nothing but. Resistor. Resistor is the resistor. Resistor is a device which is used to oppose the electric current in the circuit. Resistor is a device. Resistor is a device. Resistor is a device. Resistor is a device which is used to oppose the electric current in the circuit. Resistor is a device which is used to oppose the electric current in the circuit. Resistance is the phenomena of opposing the electric current in the circuit. Resistor is a device which is used to oppose the electric current in the circuit. Resistance is the phenomena of opposing the electric current. Resistance is the phenomena of opposing the electric current in the circuit. So rheostat is the device which is used to regulate the current, which is used to regulate the current, which is used to regulate the current without changing the voltage source, without changing the voltage source. Rheostat is a device, rheostat is a device which is used to regulate the current without changing the voltage source, without changing the voltage source is called rheostat. Ammeter is a device. Ammeter is a device which is used to measure the current. Ammeter is a device. Ammeter is a device which is used to measure the electric current in the circuit. Ammeter is connected in series combination in the circuit. Ammeter is used to connect in series combination to the circuit. Coming to the voltmeter. Voltmeter is a device which is used to connect. Voltmeter is a device which is used to connect. So parallel to the series circuit, So in parallel combination, voltmeter is used to measure the potential difference. Voltmeter is used to measure the potential difference. Voltmeter is used to measure the potential difference. Voltmeter is connected in parallel combination. Voltmeter is connected in parallel combination. So bulb, wire joining, wire crossing. Bulb, wire joining and wire crossing. Wire crossing. Okay, so this is about electrical appliances. This is about electrical appliances. Next one, we will discuss about electrical circuit. Electrical circuit. Electrical circuit is nothing but a closed and continuous path of an electric current. A closed and continuous path of an electric current is known as an electric circuit. A closed and continuous path of So I already pinned the Instagram page. So you can go to the page, check the videos once. If you like it, you can follow my Instagram page. So I pinned it. Just check once in the messages, in the chat. So I pinned it. Just go and check. So electric circuit, electric circuit, electric circuit. A continuous and closed path of an electric current. A continuous and closed path of a continuous and closed path of an electric current is known as an electric circuit. A continuous and closed path of an electric current. A continuous and closed path of an electric current is known as an electric circuit. An electric circuit. So till now we discussed about so this thing. So current is flowing, current is flowing. A continuous and closed path of an electric current is known as an electric circuit. A continuous and closed path of an electric current is known as an electric circuit. An electric circuit. Here there are 2 points are there. One is conventional current. One is conventional current. Conventional current. Second one is electric current. Conventional current. Second one is electric current. Conventional current is nothing but so conventional current. The flow of positive charges is known as conventional current. The flow of positive charges is known as conventional current because so previous so whenever they are giving this statement, so at that time, so they still at that time we didn't find out electron proton. So before that only they already given the statement. The flow of positive charges is known as electric current. The flow of positive charges is known as so that is called electric current. That is a conventional current. So instead of changing, so based on the statement, there are many theorems already given that, already proved that. Still we are using. If you change that statement, the entire theorems will go okay. So without any use. That's the reason. Instead of changing the entire thing, we better change the statement. That's the reason they change the statement. That is conventional current. Flow of positive charges is considered as a conventional current. Flow of positive charges is known as a conventional current because positive charges are moving inside of the conductor from positive terminal to negative terminal. But actually, because of the electrons movement, because of the electrons flow, the current will pass inside of the conductor. Because of the electrons movement, because of the electrons flow, so the electric current will flow inside of the conductor. That's why we are taking electric current. So conventional current is nothing but flow of positive charges. Electric current is nothing but flow of electrons. That is nothing but negative charges. So here I am considering conventional current. Positive charges will move from positive terminal to negative terminal. Positive charges will move from high potential to low potential. Positive charges will move from high potential to low potential. Whereas electric current Electrons will flow from low potential to high potential. So there is a question on this one. Will electrons will move from low potential to high potential or high potential to low potential? So explain. Like that they will ask. So the question is, we must inform, we must be clear that, so electrons will always move from, will electrons will always move from low negative terminal to positive terminal. That is nothing but low potential to high potential, low potential to high potential, low potential to high potential. Electrons will move from low potential to high potential. Positive charges will move from high potential to low potential. So this is about conventional current and electric current. Conventional current and electric current. So this is about two statement. So positive charges will move from high potential. So positive charge, see, positive terminal has high potential, whereas this one, so this one negative terminal has low potential. Negative terminal has low potential. Positive terminal has high potential. Negative terminal has low potential. So positive charges will move from high potential to low potential. Electrons will move from low potential to high potential. So this is about conventional current and electric current. Conventional current and electric current. So next one we are going to discuss about potential difference and electrical potential. Potential difference and electrical potential. Potential difference. Potential difference is nothing but work done to bring unit positive charge from one point to another point within the conductor. Potential difference is nothing but work done to bring unit positive charge from one point to another point within the conductor. So plus one is the positive charge and W is the work. Work done to bring unit positive charge from one point to another point within the conductor is called potential difference. So V equal to W by Q. V equal to W by Q. Potential difference is equal to work done by charge. So I'm taking V equal to W by Q. V equal to W by Q. So SI unit of potential is volt. SI unit of work is joule. SI unit of charge is coulomb. 1 volt is defined as 1 joule of work is done to bring 1 volt is defined as 1 joule of work is done to bring 1 coulomb of charge from one point to another point. 1 volt is defined as 1 joule of work is done to bring 1 coulomb of charge from one point to another point. Within the conductor. V equal to W by Q. V equal to W by Q. V equal to W by Q. So potential difference is nothing but work done to bring unit positive charge from one point to another point within the conductor. Within the conductor is called potential difference. 1 volt. SI unit of potential is 1 volt. So volt SI unit of work is joule. SI unit of charge is coulomb. 1 volt is defined as 1 joule of work is done to bring 1 coulomb of charge. 1 volt is defined as 1 joule of work is done to bring 1 coulomb of charge from one point to another point within the conductor is called potential difference. Coming to the electrical potential, electrical electrical potential electrical electrical potential electrical potential mm, mm, So here I am taking this a positive charge. We are doing some work. Infinity is there. So this is the required field. This is the required field. We are doing some work. To bring unit positive charge from infinity to the required field. So we are doing some work. To bring unit positive charge from infinity to the required field. So this is the required field. This is the point we need. So we need the positive charge. That's why we are doing some work to bring unit positive charge from infinity to the required field. From infinity to the required field is called electrical potential. V equal to W by Q. V equal to W by Q. So potential difference is nothing but work done to bring unit positive charge. Potential difference is nothing but work done to bring unit positive charge from one point to another point within the conductor. From one point to another point within the conductor is called potential difference. V equal to W by Q. SI unit of potential is volt. SI unit of work is joule. SI unit of charge is coulomb. SI unit of charge is coulomb. So 1 volt is defined as 1 joule of work is done to bring 1 coulomb of charge from one point to point, that is called potential difference. Electrical potential is nothing but work done to bring unit positive charge from infinity to the required field. From infinity to the required field is called electrical potential. So this is about potential difference and electrical potential. So now we are going to discuss about one more, that is Ohm's law. So just 2 minutes. So So here the potential difference across the ends of the given metallic conductor is directly proportional to current flowing through it. So the potential difference across the ends of the given metallic conductor is directly proportional to current flowing through it. V is directly proportional to I, V equal to IR. V is directly proportional to I. V is directly proportional to I. V equal to IR. V equal to IR. So R equal to V by I. R equal to V by I. So this is very very important. And here I am taking one more triangle like this. We can take this one. V I am taking up and IR. Okay, so we can multiply like this. We can multiply V equal to IR. So I equal to V by R equal to V by I. So like this we can consider. Once again you can see here, you can observe here, V equal to IR. V equal to IR. R equal to V by I equal to V by R. Okay, so this is about Ohm's law. Ohm's law is nothing but the potential difference across the ends of the given metallic conductor. So the potential difference is nothing but so potential difference. Ohm's law is nothing but Ohm's law is nothing but the potential difference across the ends of the given metallic conductor is directly proportional to current flowing through it. Is directly proportional to current flowing through it. Ohm's law is nothing but the potential difference across the ends of the given metallic conductor is directly proportional to current flowing through it. V is directly proportional to I. V equal to IR. R equal to V by I. R equal to V by I. Materials required. What are the materials required? So now we will see. Materials required. Materials required. Materials required. Okay, first one you have to take four cells. Four cells of 1.5 volts each. 4 cells of 1.5 volts each. Here I am taking. So 1.5, 1.5, 1.5, 1.5, like that we have to take 4 cells. Like that we have to take 4 cells. Okay, 4 cells of 1.5 volts each. Second one, nichrome wire. Nichrome wire is an alloy of nichrome wire. Nichrome wire is an alloy of nichrome wire of 0.5 meter length. Nichrome wire. This is the nichrome wire I am taking here. So I am mentioning here. This is the nichrome wire. Okay. So this I am taking X and Y. So this is the resistor. This is the nichrome wire. I am taking this the nichrome wire. So there is a nichrome wire of 0.5 meter length. 0.5 meter length. 0.5 meter length. Okay. So 0. This nichrome wire is an alloy of nickel, chromium, manganese, and iron metals. Coming to the third one, ammeter. I am taking ammeter, voltmeter. Fourth one is voltmeter. Fifth one is ammeter, voltmeter. Next one is switch. So this is the K I am taking switch. I am considering switch. And sixth one is connecting wires. So connecting wires I am taking connecting wires. Yes or no? These are the connecting wires. Once again, materials required. So 4 cells, 1.5 volts each, 1.5 volts each, 1.5 volts each, 1.5 volts each. 4 cells. Nichrome wire is an alloy of nickel, chromium, manganese, and iron metals. Ammeter, voltmeter, switch, and connecting wires. So these are the connecting wires. So this is about materials required. Okay, so this is about materials required. Coming to the one more. Right? Procedure. procedure. Okay, so what is the process? First one, you have to take one cell. First you have to take one cell and note down the reading of. First you have to take one cell and note down the reading of ammeter and voltmeter. First you have to take one cell. One cell you have to consider. One cell you have to consider and note down the reading of ammeter and voltmeter. So here, ammeter, first you have to connect one cell, note down the reading of ammeter and voltmeter, connect to two cells, note down the reading of ammeter and voltmeter. Next one, connect to three, repeat the process for 3 and 4. Repeat the process for 3 and 4. Repeat the process for 3 and 4 cells. Once again, here, Ohm's law is nothing but the potential difference across the ends of the given metallic conductor is directly proportional to I. V equal to IR, R equal to V by I. Okay, materials required 4 cells, so 1.5 volts each. Nichrome wire of 0.5 volts, so 1.5 volts of each. So each one 1.5 volts, 1.5 volts of each. Okay. 1.5 volts of each. Nichrome wire 0.5 meter length. So this is the nichrome wire. Okay, ammeter, voltmeter, switch, connecting wires. These are the connecting wires. Understood or not? Procedure, first connect one cell and note down the reading of ammeter and voltmeter. Connect two cells and note down the reading of ammeter and voltmeter. Connect 3 and 4. Okay, so connect 3 and 4 and mention the values. Mention the values for okay, ammeter and voltmeter. Measure the value of ammeter and voltmeter. So mention in the tabular form. Mention in this tabular form. That is, so I am taking here serial number of cells, current. So here serial number, number of cells. Here ammeter reading, voltmeter reading, V by I equal to R. So 1, 2, 3, 4. Okay. So 1, 2, 3, 4. Now you can observe here. Now we can observe once again. Okay. So one cell, take the reading of ammeter and voltmeter. Connect to two cells and note down the reading of ammeter and voltmeter. Repeat the process for 3 and 4. Okay, repeat the process for 3 and 4. Then you can see the tabular form, mention in the tabular form. So draw the graph, draw the VI graph. Okay, if you draw the VI graph, okay, there, so that will be linear for ohmic conductors, So I'm taking here, so like this I'm taking, like this. So V on y-axis, I on x-axis, V on y-axis, I on x-axis, V on y-axis, I on x-axis. If you draw the graph, so for Vi, so it will be linear. Okay, linear if I am taking, this is a linear. Okay. So linear for ohmic conductors. Ohmic conductor, the substances, the conductors which obey Ohm's law. Those are called ohmic conductor. The conductors which obey Ohm's law. The conductors which obey Ohm's law, those are called ohmic conductors. The conductor which does not obey Ohm's law, those are called non-ohmic conductors. The conductors which obey Ohm's law, those are called ohmic conductors. The conductor which does not obey Ohm's law, those are called non-ohmic conductors. So I am taking here. So one more, V on y-axis, I on x-axis. The graph is curve. Okay. So it is not linear, it will be curve. So ohmic conductor. So this is for ohmic conductor. This is for non-ohmic conductor. Ohmic conductors. Ohmic conductors means the conductor which obey Ohm's law. Ohmic conductors and non-ohmic conductors. Non-ohmic conductors. Non-ohmic conductors. Okay, conductor which obey Ohm's law, those are called ohmic conductors. So the graph is linear. Non-ohmic conductors means the conductor which does not obey Ohm's law. Those are called non-ohmic conductors. Non-ohmic conductors. I hope it is very clear to you all. I hope it is very clear to you all. Once again, check this one. Ohm's law, check once. The potential difference across the ends of the given metallic conductor is directly proportional to current flowing through it at a constant temperature. At a constant temperature. At a constant temperature, the potential difference across the ends of the given metallic conductor is directly proportional to current flowing through it. V is directly proportional to I. V equal to IR. And physical conditions also given in the textbook. You can check once. So temperature will be taken. Set a constant temperature I have to mention. Okay. So now next one more I am taking. So resistance and resistivity, resistance and resistivity, resistance and resistivity. I hope it is very clear. Now we'll discuss about resistance and resistivity. So now resistance and resistivity, resistance and resistivity, resistance, resistance, resistance and resistivity, resistivity, resistance is nothing but so the phenomena of opposing the electric current. Resistivity is nothing but so material of the property of the material. So R equal to rho into L by A. So first one here, rho equal to RA by L. RA by L. Here One more point also there. One more point also there. I will tell. I'll tell. Here, resistance is directly proportional to length of the conductor. So resistance is second one I am taking here. Resistance and resistivity. Resistivity SI unit is ohm. SI unit is ohm. Here, resistivity SI unit is ohm meter. Ohm meter. Ohm meter. How you got this one? So rho equal to RA by L. RA by L. SI unit of resistance. SI unit of resistance is ohm. SI unit of area is meter square. SI unit of length is meter. Meter get cancelled. Then O equal to ohm meter. So very important. SI unit of resistivity is ohm meter. So next one, third one, symbol I am taking. So symbol. So this is ohm and here ohm meter. And coming to the fourth one, resistance is directly proportional to length of the conductor. Resistance is inversely proportional to area of the conductor. Resistance is directly proportional to length of the conductor. Resistance is inversely proportional to area of the conductor. Here I am taking, so resistivity does not depend on length and area. Resistivity does not depend on length and area. Okay. So here resistivity resistivity does not depend on length and area. Okay. Fifth one, so resistivity depends on temperature. Resistivity depends on temperature. And here also resistivity also depends on temperature. Temperature. Coming to sixth one, it depends on material of the conductor. And here also resistivity depends on material. Okay, these are the points. Very important. Check once. Resistance R equal to rho into L by S. SI unit of resistance is ohm. Resistivity is rho equal to RA by L. SI unit of resistivity is ohm meter. Rho into RA by L. Rho ohm meter square by meter. Meter get cancelled. So this is very important. So expected for so this is for 1 mark. So 1 mark question will come. 1 mark and explanation also they will ask. And these points are very important. Okay, so 1 mark question they will ask. Okay, 1 mark. And here, so this point also very important. Each and every point, whatever I wrote on the board, each and every point, whatever I wrote on the board. So whatever I wrote on the board, very important. Very important. All points are very important. Okay. SI unit is very important. So symbol is very important and the depending formula is very important. Based on that one, problems also they will ask. Okay. Next one we will discuss about resistors are connected in series combination. Next one, resistors are connected in parallel combination. Resistors are connected in series combination. Resistors are connected in parallel combination. Now we'll discuss about resistors are connected in series. Resistors are connected in parallel. So here you can see current is same. Is equal to I1 equal to I2 equal to I3 equal to I. Current is same in the series combination. So I am taking from Ohm's law, V equal to IR. From Ohm's law, V equal to IR. So here, whatever the current is flowing, so current is same, but potential difference is different. Current is same, but potential difference is different, right? Across R1, V1, across R2, V2, across R1, V1, across R2, V2, across R3, V3. So that's why Vs equal to V1 plus V2 plus V3. So that is nothing but IRS. IRS equal to IR1 plus IR2 plus IR3. So why I am taking why I equal to, so here I already said IS equal to I1 equal to I2 equal to I3 equal to I. So that's why I am taking here. So in this equation we can take I common. Is equal to, I am taking common R1 plus R2 plus R3. R1 plus R2 plus R3. So now I am taking I common. So I get cancel. I am taking common. Then the formula is Rs equal to R1 plus R2 plus R3. Resistors are connected in series combination. Okay. Now Rs equal to R1 plus R2 plus R3. Rs equal to R1 plus R2 plus R3. So this is about resistors are connected in series combination. Resistors are connected in series combination. If n number of resistors are connected in series combination, Rs equal to Nr. Rs equal to Nr. If n number of resistors are connected in series combination, Rs equal to Nr. If n number of resistors are connected in series combination, the what is the formula? Rs equal to Nr. So this is about resistors are connected in series combination. Next one, we are going to discuss about resistors are connected in parallel combination. Now resistors are connected in parallel combination. So here potential difference is different across R1, R2, R3 potential difference. That's why BP equal to V1 equal to V2 equal to V3 equal to V. But from Ohm's law, V equal to IR, V equal to IR, I equal to V by R, I equal to V by R. So I'm taking I equal to V by R. So anyway V is common, then IP equal to current in parallel combination equal to V by RP. Now IP equal to, so current is dividing across R1, I1 is going, across R2, I2 is going, across R1 I1 is going, across R2 I2 is going, across R3 I3 is going. So current is dividing, current is splitting into three parts. Current is splitting into three parts. That's why IP equal to I1 plus I2 plus I3. So that is V by RP equal to V by R1 plus V by R2 plus V by R3. V by R3. Now we can take V common. So I'm taking V common in this. So if I take V common, both side we can cancel V value. That is 1 by RP equal to 1 by RP equal to V. I am taking common 1 by R1 plus 1 by R2 plus 1 by R3. 1 by R3. Yes or no? So 1 by R1 plus 1 by R2 plus 1 by R3. So I am taking VV common. So here, so VB get cancelled. BB get cancelled. The final answer is 1 by RP equal to 1 by RP equal to 1 by R1 plus 1 by R2 plus 1 by R3. 1 by R3. So resistors are connected in parallel combination. Resistors are connected in Parallel combination. Resistors are connected in parallel combination. If n number of resistors are connected in parallel combination, so 1 by Rp equal to N by R, Rp equal to R by N, So this is the formula, very important, very important. Make sure that you are learning this one. Okay, so that's enough. So this is about resistors are connected in parallel combination. This is about parallel combination. Resistors are connected in parallel combination. Resistors are connected in parallel combination. Clear? Yes. So now we will discuss about one more, that is heating effect of electric current. Heating effect of electric current. Now heating effect of electric current. Heating effect of electric current. Heating effect of electric current. So V equal to W by Q. V equal to W by Q. V equal to W by Q. So W equal to VQ. W equal to VQ. P equal to the rate of doing work. P equal to W by Q. P equal to W by Q. So I am considering here P equal to W by Q. P equal to W by Q. P equal to W by T. So rate of doing work. P equal to W by T. So rate of doing work. P equal to W by T. So that is nothing but VQ by T. VQ by T. P equal to, we know Q by T is I. Q by T is I. So I am taking Q by T is I. So the rate of flow of charge is called current. Rate of flow of charge is called current. So V equal to Q by T. Is VI. P equal to VI. Energy is given to the conductor. So that is E equal to P into T. So whatever the energy is given to the conductor, that will become in the form of heat. Okay, so heat produced in the conductor, that is equal to H equal to P into T. P we know, Vi into T. V we know, V equal to IR, V equal to IR, V equal to IR. So H equal to IR into I into T, that is H equal to I square RT. H equal to I square RT. H equal to I square RT. So this is about heating effect of electric current. Heat produced in the conductor. Heat produced in the conductor is directly proportional to square of current. Heat produced. Heat produced in the conductor is directly proportional to square of current. Heat produced in the conductor is directly proportional to resistance. Heat produced in the conductor is directly proportional to time. So this is also known as Joule's law of heating. Heating effect of electric current is also known as Joule's law of heating. Joule's law of heating. Okay. V equal to W by Q. So W equal to VQ. From this formula only we are taking. From this formula only we are taking W equal to cross multiply. So V into Q. Okay. So from this only we are taking this formula. So here W equal to V into Q. So W equal to VQ. We know electrical power equal to rate of doing work. Rate of doing work. So W equal to V into Q by T. So rate of flow of charge is called current. Rate of flow of charge is called current. So P equal to V into Q by T is nothing but VI. P equal to VI, V equal to IR, V equal to IR, V equal to IR. Energy is given to the conductor. Energy is given to the conductor, that is P into T. Whatever the energy is given to the conductor, that will become in the form of heat. H equal to P into T. So we know P equal to VI, V equal to IR, IR into I into T. H equal to heat produced in the conductor. Heat produced in the conductor is directly proportional to square of current, directly proportional to resistance, directly proportional to time. Okay. So this is about heating effect of electric current. Heating effect of electric current. That is also known as Joule's law of heating. Joule's law of heating. Yes or no? Next, applications of heating effect of electric current. Electrical cooker, electrical iron box, electrical cooker, electrical iron box, and also water heater, and electrical oven and room heaters. So these are the electrical appliances which will work on heating effects of electric current. Heating effects of hair dryer also. It depends on heating effect of electric current. I hope it is very clear. Applications of heating effect of electric current. They will ask applications of heating effect of electric current. Okay. Next one, commercial unit of energies, kilowatt hour. Commercial unit of energies, kilowatt hour. 1 kilowatt hour equal to 3.6 into 10 power 6 joule. 3.6 into 10 power 6 joule. So that is one point. And coming to the one more point, that is we can take short circuit. Short circuit is nothing but the direct contact of live wire and neutral wire takes place. Heavy amount of current will be drawn from the mains. Heavy amount of current will be drawn from the mains. The direct contact of live wire and neutral wire takes place, then heavy amount of current will be drawn from the mains. So potential of live wire is live wire potential. Live wire is positive terminal, red color. Okay. Neutral wire. Neutral wire. Negative terminal, black color. Earth wire, green color. So red color. Green color. Okay. So now you can observe live wire. Now you can observe live wire is a positive terminal, red color. Neutral wire is negative terminal, black color. Earth wire is green color. So here I am taking fuse. One more fuse is there. Fuse is a device. Fuse is a device. Fuse. Fuse and earthing. Second one is earthing. Fuse is a device which fuse is a device. Fuse is a device which breaks the circuit, which melt and breaks the circuit when the current is exceeding the minimum limit or required limit. So if the extra current is flowing, so than required limit, if extra current is flowing in the circuit, so fuse melt and breaks the circuit and it safeguard the appliances, it protect the appliances, that is the fuse. And even earthing also, extra current is there for the metallic bodies, extra current is there, that will send to the ground, okay, that is the, these are the two safety measures, so we are using in household, okay. So that's enough. Series combination and parallel combination. In household we are using parallel combination. I hope it is very clear about electric current. So from starting onwards, what we discuss, we'll discuss now. Electric current, the rate of flow of charge, SI unit of current is ampere, SI unit of charge is coulomb, SI unit of time is second. And the next one, electrical appliances, cell, battery, open switch, closed switch, resistor, rheostat, ammeter, voltmeter. And next one, wire joining, wire crossing, bulb. And next one about electric circuit. A continuous and closed path of an electric current is known as an electric circuit. A continuous and closed path of an electric current is known as an electric circuit. After that, potential difference and electrical potential. Potential difference is nothing but the work done to bring unit positive charge. From one point to another point within the conductor. Is called potential difference. Electrical potential is nothing but work done to bring unit positive charge from infinity to the required field. That is electrical potential. And coming to the Ohm's law, at a constant temperature, the potential difference. The potential difference across the ends of the given metallic conductor is directly proportional to current flowing through it at constant temperature. Already said, at constant temperature, the potential difference across the ends of the given metallic conductor is directly proportional to current flowing through it. V is directly proportional to I, V equal to IR. That is about Ohm's law. Materials required: 4 cells, 1.5 volts each. So like that, 4 cells we have to take. After that, nichrome wire is an alloy of nickel, chromium, manganese and iron metals. Ammeter, voltmeter, resistor, ammeter, voltmeter. So already nichrome wire is completed. Ammeter, voltmeter, switch, connecting wires, connecting wires. Okay, so this is about materials required procedure. Connect one cell and take the reading of ammeter and voltmeter. Connect to two cells and note down the reading of ammeter and voltmeter, and repeat the process for 3 and 4 and mention in the tabular form. Draw the graph for VI. VI graph gives VI graph gives linear line. So starting from origin. Okay, so for ohmic conductors only. For ohmic conductors only, the graph is linear. What are the ohmic conductors? The conductor which obey Ohm's law, those are called ohmic conductor. The conductors which obey Ohm's law, those are called ohmic conductor. The conductors which does not obey Ohm's law, those are called non-ohmic conductor. Non-ohmic conductor means the conductors which does not obey Ohm's law, those are called non-ohmic conductor. Conductors which obey Ohm's law, those are called ohmic conductors. Ohmic conductors and non-ohmic conductors. Next one. So one more point we are going to that is resistance and resistivity. Resistance is a phenomena of opposing the electric current. So SI unit of resistance is ohm. It depends on length, it depends on area of the cross section, it depends on temperature, it depends on material. And coming to the resistivity SI unit is ohm meter. Resistivity does not depend on length and area. Resistivity depends on temperature and the material of the conductor. After the resistors are connected in series combination, RS equal to R1 plus R2 plus R2 R3 plus RS equal to R1 plus R2 plus R3. So resistors are connected in parallel combination. 1 by Rp equal to 1 by R1 plus 1 by R2 plus 1 by R3. So those are resistors are connected in parallel combination. So resistors are connected in series combination or resistors are connected in parallel combination. After that, heating effect of electric current V equal to W by Q, W equal to VQ, P equal to W by T. So W equal to VQ, Q by T is I, P equal to VI, E equal to PB. So whatever we are taking, P equal to P into T, E equal to P into T, P equal to VI. So H equal to I square RT, H equal to I square RT, H equal to I square RT, H equal to I square RT. Heat produced in the conductor is directly proportional to square of current. Heat produced in the conductor is directly proportional to resistance. Heat produced in the conductor is directly proportional to time. Yes or no? Commercial unit of energy is kilowatt hour. 1 kilowatt hour equal to 3.6 into 10 power 6 joule. Okay. So next one. A short circuit, the direct contact of live wire and neutral wire takes place. The direct contact of live wire and neutral wire takes place. Heavy amount of current will be drawn from the mains. Okay, so fire will occur in the building. And next one, overloading. High voltage appliances on at a time. High voltage appliances on at a time. Those are like a washing machine, geyser, fridge, and like a grinder. So this type of electrical appliances, high voltage appliances on at a time, heavy amount of current will be drawn from the mains. It leads to the short circuit. Okay, so this is about overloading. And next one, overloading completed, short circuit completed. So live wire positive wire red color, neutral wire negative terminal black color, earth wire is green color, fuse and earthing. So that's enough. So this is about electric current. So CBSE Grade 10 Physics. If you like this video, please do like, share and subscribe to Student the Brand. So you can go and check my videos. You can go and watch my videos. So there are many videos are there related to physics content. Okay. So with respect to time, if the object moves, so we can say object is in motion. If the object is not moving with respect to time, so that we can say at rest. Okay, done. Come to the point. Next one. So there are 4,000 plus videos are there. So you can go and check my YouTube channel. So you can watch the playlist and live classes, short videos are there. So go to the playlist and check all the videos. So if you like the content, do like, share and subscribe to Student the Brand. Inform your friends, ask them to join to the class, listen to the class, learn from Student the Brand. Okay, so channel. Thank you so much. This is our Shiva sir from Student the Brand. We'll see you in the next class. So class timings 11 a.m., 3:30 p.m., 6 p.m. and 9 p.m. Once again, class timing every day. These timings are fixed. These timings are fixed class timings. Live class timings. Live classes or live class timings. You can say live class timings directly. So first class 11 a.m. morning. Second one 3:30 p.m. Third one 6 p.m. and fourth one 9 p.m. every day. Every day these class timings are fixed. Every day. So just check once. So these classes are every day. Every day you can get the timings. So thank you so much for joining and attending and listening and giving an opportunity to teach the class. Thank you so much. This is Siva sir from Show and the Brand.